In this presentation, we will learn how to detect the falling edge of an input signal using Arduino. Let us try to define the objectives of this presentation. The objective is to detect the falling edge of a digital signal using Arduino Uno. For achieving this objective, a simple hardware arrangement is proposed here. The input signal is applied to pin number 5 of Uno. External hardware is very simple. Two resistors, one of 1 kilo ohm and another of 10 kilo ohms, they are connected in series. The three fly leads are connected as shown. End 1 is connected to 1 kilo ohm resistor, end 2 is connected to 10 kilo ohm resistor, and end 3 is connected to the junction of 1 kilo ohm and 2 kilo ohm resistors. Connect end 1 of fly lead to pin number 5 of Uno. Connect end 2 of fly lead to ground of Uno. After connecting the fly leads as mentioned earlier, the default potential on pin 5 will be 0. Insert end 3 of fly lead into plus 5 volts. Now the potential on pin 5 will be plus 5 volts. Now pull out the end 3 of fly lead. The potential on pin 5 will be 0 now. This is the falling edge of signal applied on pin 5. The above mentioned process is explained here using a time diagram. At time t0, end 1 of a fly lead is connected to pin 5. End 2 of the fly lead is connected to ground and end 3 of the fly lead is left open. Pin 5 voltage is 0 and pin 13 voltage is also 0. At time t1, end 3 of the fly lead is inserted in 5 volts. This leads to pin 5 voltage to become plus 5 volts. Pin 13 voltage still remains low. At time t2, end 3 of the fly lead is pulled out from plus 5 volts. This will lead to pin 5 voltage to collapse to 0. That is, falling edge of pin 5 voltage is encountered now. Pin 13 voltage goes to plus 5 volts and stays plus 5 volts for 1 second till T3. Pin 5 voltage remains to default 0 volts. Now let us define the problem critically in the form of a problem statement. To detect the falling edge means when the digital signal applied to pin 5 is going from logic high to logic low. Indicate this happening by glowing an LED connected on pin 13 for 1 second. Take care of a glitch that mostly appears when manually inserting the fly lead into plus 5 volts. Following steps are to be followed for the implementation of problem statement as mentioned earlier. Step 1. Define integer variables to represent pin 5, pin 13 and 1 to store read data from pin 5. Also initialize this last variable to a 0 value. In void setup function, define pin 5 in input mode and pin 13 in output mode. Now we will go for void loop function. Step 3. Digitally read pin 5 and assign the read value to the variable to store. Repeat step 3 till pin 5 attains logic high potential. This means when pin 5 attains logic high potential, program will come out of step 3. Wait for 100 milliseconds. This overrides the glitch that usually appears while manually inserting the fly lead into plus 5 volts socket. Step 5. Pin 5 has attained logic high potential. Digitally read pin 5 and assign the read value to the variable to store. Repeat step 5 till pin 5 attains logic low potential. This means when pin 5 attains logic low potential, program will come out of step 5. Potential at pin 5 has become 0 from 5 volts. This means the falling edge of signal applied at pin 5 has been detected. Step 6. To indicate that falling edge has been identified, write digital high on pin 13. Step 7. Wait for 1 second. Step 8. Write digital low on pin 13. And now to go into the loop, go back to step 3. Now let us convert the steps mentioned above into an Arduino code. First, we will define the variables that we will be using in the program. Int pin 5 equal to 5. Pin 5 is defined as an integer variable and assigned to pin number 5. Int pin 13 equal to 13. Pin 13 is defined as an integer variable and assigned to pin number 13. Int var equal to 0. Var is defined as an integer variable and assigned an initial value of 0. All the variables which we will be using in the program have been defined. Now we will be defining the functions of different pins in void setup function. Type void setup, open the small bracket and close the small bracket. In next line, open the curly brace. Go to the next line, give a tab space, type pin mode, open the small bracket, pin 5 comma input, close the small bracket. This means pin 5 is defined as input pin. Go to the next line, give the same tab space, type pin mode, open the small bracket, pin 13 comma output, close the small bracket. This means pin 13 is defined as output pin. And finally close the void setup function by putting the closing curly brace. All the pins which we will be using here have been defined for their operation as input or output. Now we will be writing code for void loop function. Type void loop, open the small bracket, close the small bracket. Go to the next line, open the curly brace. Go to the next line, type in comments. We are entering while loop with value of integer variable var equal to 0. Type in the next line with a tab space while open the small bracket, var equal to 0, close the small bracket. Go to the next line. With the same tab space, type opening curly brace. Go to the next line. Give two tab spaces. Var equal to digital read, open the small bracket, pin 5, close the small bracket. Go to the next line, give one tab space and type closing curly brace. Now, what is the meaning of this loop? Coming out of loop when var has become 1, that is potential at pin number 5 when this goes logic high, the control will come out of this loop. Generate a delay of 100 milliseconds. For this, type give a tab space, delay, open the small bracket, 100, close the small bracket. This means wait for 100 milliseconds, and this is required for avoiding any glitch. Now we will write while function. So type with a single tab space while, open the small bracket, var equal to 1, type closing small bracket. Go to the next line, open the curly brace with a single tab space. Go to the next line, give two tab spaces, type var equal to digital read, open the small bracket, pin 5, close the small bracket. Go to the next line, give a single tab space and type the closing curly brace. In the comment, var has become 0, falling edge has been detected. Next line, with a single tab space, type digital write, open the small bracket, pin 13 comma high, close the small bracket. Go to the next line, delay, open the small bracket 1000 and put the closing small bracket. Next line, with the same single tab space, type digital write, open the small bracket, pin 13 comma low, close the small bracket. And in comment next you write go back to beginning of the void loop, and without any tab space in the next line, put the closing curly brace. This is the complete program. The program which we have just discussed has been typed in the Arduino IDE. The two slides now, they are just screenshots of the codes which have been written in Arduino IDE, and these are the screenshots for those codes. This slide shows the remaining part of the code which has been written in Arduino IDE. In this setup, it is quite visible. The right side fly lead is connected to pin number 5, which is the input pin in our setup program. The left lead, which is white in color, is connected to ground. So the voltage going to pin number 5 is logic low, and my program reads pin number 5 as logic low. The moment I insert the third fly lead into plus 5 volt socket, the voltage going to pin number 5 is logic high. The moment I pull this third fly lead, the voltage will fall down on pin 2 logic low, that is falling edge, and in such a case the program should glow the LED connected on pin number 13 for 1 second. Let's see whether this happens or not. It is easy to see, the LED glows for 1 second.